we can do another test with some other models, and rather than running all these steps again, I'm going to make a small function here, and let's now do. Let's running decision trees and random forest. I have some surprises. So now I want to put this in a function, and this is ML. This function will have a model that can be any model. It doesn't have like any model. So that model, I'm going to run a standard scaler, and I'm going to put it in here. And do a with the x underscore train and with the y underscore train. So and then return the pipe model. Okay. Let's do that. Okay. So what I'm going to do is now I will have a forest regressor, which is going to be equal to a random forest regressor. And we can have a decision tree regressor, which is equal to decision tree regressor for the time being. Let's use those two. And we have this function. And let's see for the decision tree. So let's actually we have this little function here, and I'm going to put it as my def okay, let's see what we have in here. So this plotter will take in this case I'm doing the pipeline. So let's take the model, and I would take the model name. So just to be able to plot. So I'm going to take the model, I'm going to put it in here, and the model name, so that I can plot the right model name, add it in here, and also plot it in here. Okay. So I should have a plotter, the model name. Okay. So it means that I can do now in fact, let's do this. My decision tree is going to be equal to my generic model, and I'm going to pass a decision tree straight away, decision tree regressor. It's a bit aggressive because I don't have control of the decision tree. I'm not going to take, I'm not going to play with the parameters, but just to produce the model very quickly. And the next step is I'm going to do the plotter. And in the plotter, I'm going to take my decision tree model, and I'm going to plot decision BHP underscore D3 DT. So let's see if that works. Boom. Plotter is not defined. Plotter, strong plotter. Okay. Okay. That wrong. Okay. So decision tree actually looks quite well in the first well. Decision trees usually tends to overfit. They look quite well. But you can see that due to the nature of the decision trees, And I haven't explained that, and I'm not going to cover that, but you can see that it's mainly going for a rule-based classification, and you can see that it's we're paying the price here in the plot. So the other thing that we're going to do is do the same, but now let's do a random forest. Now let's do a random forest, and I'm going to pass here random forest. And of course, you know that there are many parameters that I'm not using at the moment here, but it's just to illustrate. So this is a random forest plot. Let's see what would happen there. Actually, the random forest, it kind of doesn't have the issue of the kind of a flat decision points and kind of a steps, because in the random forest we have many decision trees, and actually the default is 100 decision trees, but you can see that it's actually struggling to get a good quality of a model. It works quite nicely in the two wells where we fit the original data, but it's not so good in the other couple of wells. So still the linear model is doing a much better job with the prediction. So just as a matter of fun, I'm just going to try artificial neural network, but I'm not going to explain the details. So this is running an artificial neural network. And this is a very simple one. I haven't worked too much on it, but just I'm keen to see what are the results here. And in this case, I have my predictors, and we have two hidden layers with 32 nodes each. We are predicting whatever, we're predicting the bottom hole pressure at the end of in the last layer. And as activation function, I was using a ReLU that it's deciding the weights on the intermediate layers. So I'm using an optimizers here, Adam, and this is the learning rate of optimization function. So I'm not going to go through the details of that, but let's see if that actually does something interesting. First, as you can see, the first thing is that it's taking a bit of time.
Alejandro?
Yes.
Sorry to interrupt you by the time this is complete. Just wondering, for the standard scale, you use fit instead of fit transform. Is there any reason why you did that?
So you do a fit. Fit transform is to do the two steps in one go. So let's say you want to use the train data, and you want to fit and then transform and then do prediction. You can do that. But at the moment, what I'm trying to do, it's generate the model. So that's what I'm using the fit. But fit transform is what you want to do the two steps. So let's say, for instance, the scalar. In the scalar, you want to fit.
Yes.
And then in a later step, you want to transform the data. I guess when you saw the pipeline, I put in the pipeline, what I'm doing is fitting the model, not the scalar.
Right. Yeah.
Okay. So let me see if I can use the same plotter here. Let's see if this works. So now I run the model. As you can see, it took a bit more of time. It's quite a few iterations. So the neural network is a bit more involved. It takes a bit more of iterations. And probably this model, it's really an overkill for a neural network. So in this case, my neural network model is called model, so to create it. And this is my bottom hole pressure with my, actually, this is my ANN regression. And this is my neural network with my ANN. Let's see if that works. No. something there that wouldn't work. Well, in any case, I think what we can do is, oh, of course, because this is doing the fit already internally. That's why it's not working. That's why it's not working. So let's do this. Let me run it again. And this is the last thing that we will do before we open for questions or any comments that you want to make, guys and girls. So there you go. So now I'm going to add I'm going to predict based on my model. I'm going to use the predictors here, and I think that should be fine. Let me see if I can take the model here. No, that's going to screw up the model. Let me run that and then just plot it as it was before. Okay. So that's a nice model there, as you would guess, but this is completely horrendous here. Not quite sure. Yeah, we're having troubles there. I'm not saying the neural network is a bad model. I'm just saying that we need to work quite a bit more on fine-tuning the neural network before we can use it. And as you can see, probably a neural network is an overkill on this particular problem. It's with a linear regression. So far, without working too much, we had a very good result. And I have observed that quite frequently. So don't underestimate the power of a linear regression, especially linear regression when you have square coefficients. It's actually quite powerful, and you might be well off with just a linear regression that is quite cheap to run. Right. So I hope I know it was short, but I hope that exercise was illustrative. And just would like to hear a bit from you guys, from everyone, please. Any feedback, any comments would be great to hear.
I think thank you so much, Alejandro. I think this is really great and would be really nice to have more of these, like more often.
Yes, I try this here. I try.
You know, you're busy, yeah. So
I'm also trying to invite some other speakers as well as we move forward. I think there are so many people do interesting stuff there. But there is something that we need to really battle a bit in the oil and gas industry in particular, and is sharing. And I think if you see what's happening in other industries, the industries are more open, and open source is more widely used in other industries. And rather than explaining you philosophically what I have done, I've gone through other seminars and events in other industries where people actually sharing how they have done their particular work. And yeah, it's we have to change a bit the minds and hearts.
No, I agree. Other industries are more open, and that's why when Equinor shared the Volve data set, we see a lot of examples and a lot of people working on the data set. It's really something amazing to see. Yeah.
Yep, absolutely. Yes, this Jupyter, it's will be shared, and actually let me do it straight away. The only thing that I would like to fix is that I made a mistake on the naming convention at some point. I think when I was naming here, this is random forest. It wouldn't affect the results, but just for the sake of having the right results. So it would be great if you play with it and come up with something different as well, or if you have any ideas, yeah, we're open to hear.
Alejandro, hi,
Yes.
Jamal over here.
Hey, Jamal. Glad
Thank
that
you
connected.
for this great information that you shared today. I have a question for you: is that will this analysis work in a wells in where you have, for example, commingle between different reservoirs, or you have to maybe insulate data from each reservoir to try to do this analysis?
So that's a very good question. I think what I would do is take some of the reservoir properties as well as input.
Okay.
So rather than only relying on, because I use only well data here, but you could take the say top formation, top, bottom, whatever number of formation. You can label the formations as formation 1, 2, and 3, and then take the thickness, the porosity, the permeability, and then of every one of the formations, and see if a model is able to deal with that.
Okay, interesting. Okay.
Yes.
Okay. Thank you, Alejandro.
No, you're welcome, Yaman. Yes, Dami, I will be sharing the video in the Orca Hub YouTube channel. Please follow up, because I'll keep sharing more stuff there as we move forward. And some of you have gone to a training that Adolfo and myself are giving, which obviously we got at a much lower pace, and we explain things in detail. And so you're also welcome to check the brochure and see if you want to join us in one of those trainings. And for those that I see, some of you that some of you have already taken the training. I hope that you're taking more advantage of the exercise by understanding a lot of the steps and in detail of what I'm doing, and some of the steps that perhaps you don't understand in detail. I'm pretty sure that you might be able to follow up. Thank you, Alexis. Thanks for connecting. So yes, I'll put this in the GitHub. I'll do it straight away. Actually, let me do that straight away, because
Alejandro,
yes.
Just a question. I saw a post on LinkedIn by you. There is a March training on Python.
Yes. Yes.
Is that rate fixed whether you're a student or like a professional, or do you have a different rate for students?
We can talk about what I usually do is that I do sessions for the universities, and hopefully they can catch up with Orca Hub later on. But we can organize a session for a university. I know that the course price could be prohibitive for a student, so we have the option of offering a session for the university, and then they catch up with the Orca Hub channel. More on themselves, but the course is it has that price tag, because obviously we dedicate like 30 hours on this over 3 weeks to answer the questions and to go through the details of Python and some other things.
Right. Okay, if you're interested, I can talk to a few colleagues at the university, and we can maybe organize a session.
Yes.
At
Yes.
the
Which university are you in?
University of Calgary.
Okay, I did already one for the University of Calgary. Yes, you were there, no?
Oh, that was for the ASEC. Yeah, that was for the.
Oh, yes.
Yeah,
yes.
yeah.
Yes, so yeah, we can organize another one. It might not be that different to the one that I already did, but if you find a different set of students, we might be able to repeat it.
Yes, I'll text you or like a message you on LinkedIn, and we can coordinate from there.
Okay.
Thank you.
Great.
Thanks.
No, thank you. Okay, well, thank you, everyone. I am going to stop the recording, and I'm going to be connected just in case there are more questions while I put everything on GitHub, and yes, let's do that. Take care, everyone.